Okay, good. So we are in for lesson 5 and we want to look at lines. We want to look at lines and under this, what we specifically look at is vector equation of a line. Vector equation of a line. That's what we're going to look at. A vector equation of a line. Now, here what we do, specifically what we do here is, all right, so what we do is, we say for example, we're having the Cartesian plane. The Cartesian plane whereby this one is the x-axis and this one here is the y-axis. And when we have that Cartesian plane, we are imagining we are having a line like that and also there like that, whereby this line is starting from point say A to point B in that format. All right, A to point B. Now, this point in the middle, point R, we are calling it a general point. And I told you that what we call a general point, so whereby this A has x1, y1, z1, this B has x2, y2, z2, and this R, a general point with it doesn't have anything like a subscript. So what we do here is, if you have a line of that order, A, R, B, then we all know that this is from the origin. Now, when we connect from that A, the origin, and when we connect from that R to the origin, and when we connect from that B to the origin, they are like that. And now we know that for this to give us OA, that will give us OR, and that will give us OB, like that. But looking at these points here, these points are collinear. They are on the same line. And we looked at what we call collinear points. That once points are collinear, like say for example, if they are like this, once points are collinear in this order, A, R, and B, once points are collinear, you have a right to come and put these dotted lines like that. Like that. Then in the end, you see that they are parallel. Collinear points are also parallel lines. So we shall now say, AR is parallel. AR is parallel to RB. Like that. AR is parallel to RB. Then what we're going to say, we shall say that now AR is equal to, now we not put an equal sign for parallel, then you shall put in a constant of your choice, a constant. Some people here prefer using lambda. You can use K, you can use lambda, you can use mu, anything. So lambda RB. You all know that for parallel vectors, we have a right to write like that. AR is equal to lambda RB. Now this one here will give us equation of a line. Okay, now we shall now start off and say that AR vector is equal to lambda RB. Lambda RB. Now let's analyze here. We realize that here we're going to have, oh sorry, here we would have said that AR, sorry, we would have said like that, AR is parallel to AB. This is also true. AR is parallel to vector AB. So if AR is equal to parallel to vector AB, lambda AB, like that. So now, what does it mean? Let's use the position vectors here. This will now be OR vector minus OA is equal to lambda OB vector minus OA, like that. Then also, you come and know that this OR is vector small r and this OB is vector small b and this OA is vector small a, maybe for the simplest of naming. So OR is equal to this. We have OR minus OA is equal to lambda AB. Now I want to make OR the subject. Why OR the subject? Because yeah, it is the general point. All right, so now we shall have that OR vector is equal to OA. It has crossed the equal sign to become a positive plus lambda OB minus OA. these are vectors. Please, I may forget to put, but you must be considering it like that. So this will now mean that small r is equal to vector A plus lambda B minus small a. I'm substituting that. OB is that. OR is that. OA is that. All right, good. So now here we shall say in our side work, let mu equal to vector B minus A. Please cram this from now. Let mu equal to vector B minus A. And now in simple terms, this mu here is a parallel vector. Now, what we're going to do in the place of B minus A, we shall put there mu. So we shall now have R vector is equal to vector A plus lambda, okay, plus lambda mu. Now this is the general equation of a line. Where you see mu is a parallel vector. How do you get parallel vector? The parallel vector comes after you have subtracted two vectors. After you have subtracted two vectors, you get parallel vectors, please. After you have subtracted two vectors, you get parallel vectors. Or sometimes, instead of parallel, they may call it directional. A directional vector. Still, that's all they're saying. So now this one here, whereby, here you must know that this mu, okay, maybe I can define here, I can say R is general point on a line, general point on a line. Then small a is a point on a line, Then mu is a parallel. Whenever you see that parallel, just not subtracted. Parallel or directional vector. Okay, now that's what we have. Another thing which you must know is the vector equation of a line can be written in three forms. So note, shall we say, the vector equation of a line can be written in three ways. Okay, I'll use three ways. The first one is it can be Cartesian equation. Yep. It can be parametric equation. Then it can be vector equation. So it can be written in three ways, as simple as that. So now we want to see how can we write them. In parametric, Cartesian, and vector format. All right, so now let's proceed and see how we can write this in parametric equation. Now this one here is the vector equation, the way it is here. Vector equation. So it means that out of the three categories remaining with Cartesian and parametric. Now let's see how do you write it in parametric equation. So parametric equation. Now from there we shall now say that from R is equal to small a plus lambda mu. Yep. But now the small r from the start, we said that r is same as x, y, z. So r is same as x, y, z is equal to, the a was x1, y1, z1. You can see that, plus lambda. Now our mu here is a parallel vector, which means subtracting b minus a. You all remember that. So b minus a, the b was x2, y2, z2, minus x1, y1, z1. So this one here is what we call a parallel vector, point on a line, general point, like that. Now, so how shall we write in parametric form? Now, in parametric form, you simply equate. So we shall now say that x is equal to x1 plus lambda plus lambda plus lambda x2 minus x1. Then y is equal to y1 plus lambda y2 minus y1. Then z equals to z1 plus lambda z2 minus z1. Now, with what we are having here, this one here is a Cartesian equation, rather a parametric. Parametric means that just left in parts. Parametric, these are parametric equations. So here, these ones here are parametric equations. Parametric. When you just leave it in terms of x is equal to that, y is equal to that. So it is a parametric equation of a y, of a line, sorry, parametric. Then let's see, how do we write now a Cartesian equation? How do we write a Cartesian equation? So to write a Cartesian equation, maybe allow me to call this equation 1, this equation 2, this one equation 3. How do we write it in Cartesian form? So I will say from. So here I will say make lambda the subject, make lambda the subject, make lambda the subject in the above equations, in the above, okay, equations. So making lambda the subject, let's make lambda the subject here. I realize that lambda will be equal to, please, in this equation, don't make lambda the subject. You see that this will come this side. So it will be now x minus x1 divided by x2 minus x1, like that, comma, lambda is also equal to, here, y minus y1 over, just an edit of this, y2 minus y1, comma. Then have lambda is also equal to, I've made lambda the subject here, so this goes this side, divided by that. So finally lambda is equal to z minus z1 over z2 minus z1. Then from there, since you say that here lambda is equal to this, lambda is equal to that, lambda is equal to that, means that you have a right equal to this, equal to that, equal to that. So generally you now say x minus x1 over x2 minus x1, okay, is equal to, okay, y minus y1 over y2 minus y1, and also equals to z minus z1 over z2 minus z1, like this. And now this one here is a Cartesian equation, a Cartesian equation of a line. Okay, let's still move on. That's the science which we need as per that.